Hello guys, today we'll be doing LeetCode question 605, can place flowers. Question is an easy question, and it is, you have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and an integer n return true if n new flowers can be planted in the flower bed without violating the no adjacent flowers rule and false otherwise. So, example here, 1, input flower bed is an array with 1, 0, 0, 0, 1, n is equal to 1. The output is true because can one flower be planted? Yes, the flower can be planted here because the numbers beside them are 0. The numbers beside it is 0 and the numbers beside 1 are also 0. If the number is out of bounds, that was taken to be 0. So all of these can be, so one flower can be inputted. Example 2, flower bed is the same array but n is equal to 2. The output is false because you can't input 2 flower beds, you can only input 1 maximum here without having 1 as adjacent. So the way we'll do this is by looping through the array. We check if the surrounding values are either out of bounds or 0. Then we change the value to a 1 and we decrement n. And we pretty much return true if n is equal to 0 or less than 0. Otherwise we return false. So let me show you how to do this on the whiteboard. So let's say we have the same array. So it's 1, 0, 0, 0. But let's change it so we have a 1, 0, 0. And n is equal to 2. So what we'll do is we'll loop through the array. We'll have I is equal to 0. So now we are here at 1. We check if 1 is equal to 0. 1 is not equal to 0. So we go back and we increment I by 1. So now I is equal to 1. And then we check our position 1. Is 1 equal to 0? Yes. Is the number before it, so I minus 1 equal to 0? No. So we proceed. Because both have to be equal, both surrounding values have to be equal to 0. Go back, and we increment I is equal to 2. Now we are here. Is the value of I equal to 0? Yes. Is the value before I equal to 0? Yes. Is the value after I equal to 0 out of bounds? Yes. So then we change the value to 1 and we decrement n. So now n is equal to 1. Now we increment I. So I is now equal to 3. We check if the value at 3 is equal to 0. Is the value before it equal to 0? No. So we go back and we increment I. So I is now 4. We check if the value at 4 is equal to 0. No. So we increment I. I is now equal to 5. Is the value at 5 equal to 0? Yes. Is the value before 5 equal to 0? No, that's 1. So we increment I again. I is equal to 6. We are here. Is that equal to 0? Yes. Is the value before equal to 0 or out of bounds? Yes. Is the value after equal to 0 out of bounds? Yes, out of bounds. So we know we can put a flower here. So we change this to 1. And we decrement n. So now n is equal to 0. Now we return true if n is smaller than or equal to 0. Because that means we've planted, for each pot that we plant, we decrement it. So we know we've planted 1 pot. And so if n is equal to 2 and we planted 2 pots, it will be 0. If we planted more than that, it will also be smaller, which means it passes the test case because we can plant at least that amount of flowers. So let me show you how it's done in code. So the first thing we do is we create a for loop. So we let I is equal to 0. So because I is smaller than flower bed dot length. Then we increment. Then we have to check if the value is equal to 0. So if flower bed I is equal to 0, then we have to check if the surrounding values are also equal to 0 or out of bounds. So and do flowerbed I minus 1 is equal to 0, or flowerbed I minus 1 is smaller than, not flowerbed I minus 1, if I minus 1 is smaller than 0. So that either means that checks if the value before is equal to 0 or if it's out of bounds. And after that we check if flowerbed I plus 1 is equal to 0, or if that value is out of bounds as well, so I plus 1 is bigger than nums, so bigger than or equal to nums.length, because again nums.length is out of bounds. So if I plus 1, we don't need to do if it equals to nums.length, then we know it's out of bounds. Well, let's do bigger than or equal to, just in case, if that won't make any difference. So if that passes, then we set a value. So flowerbed I to 1. So the reason being, if we don't change it, if the next value is 0, we might increment that value to 1 as well, and decrement n, and so that will fail because it's incorrect. Then we decrement n to signal that we've found one flowerbed that we can plant, and then we return true if n is smaller than or equal to 0. Let's run. Wrong answer. 1 output is true. Sorry, not bigger than. I meant smaller than. So now let's run. As you can see, it passes. Let's submit. Nums is not defined. Oh, sorry. This is flowerbed.length. Now let's submit. So as you can see, this is the fastest method. This is a time complexity of O(n). As worst case, we're looping. No, in fact, we are looping through the whole array of flowerbed, and it's a space complexity of O(1), as we're not storing any extra variables. Thanks for watching.